Today we're going to look at lesson 6-2. We are going to graph reciprocal functions, which is another one of your parent functions. So this is a function that you are going to need to learn and memorize. It's not that difficult. And this is our parent function today. F of x is equal to 1 over x. So this entire unit 6 is about fractions. So they are called rational functions because a ratio is a fraction. So this is our parent function, 1 over x. So one of the things that you need to realize about this parent function is the domain, which are your x values, is restricted. We cannot put just any number in this denominator. There's only one value that the denominator cannot be, and that is 0. So you might want to add here that x cannot equal 0. And x in this case represents the whole denominator. You're going to soon learn that this denominator can change, but for right now this is the very simple 1 over x parent function. So let's go ahead and graph that function. We are going to get a table of values, and we're just going to select some values for x and come up with values for y. And we're going to get things on these graphs called asymptotes. Asymptotes are part of our graph that our graph itself cannot cross. It's kind of like a wall or a barrier, and you'll see that happening with our values. We're going to choose some negative values and some positive values and go from there. So I'm going to start with, I'm going to put a lot of values on here, some of which we may or may not be able to graph because they're so tiny, but some we can. So if I start with -5 and I substitute in -5 in here for x, I get 1 over -5, which is a -1/5. Then if I substitute in -4 and I put in -4 here, I get -1/4. I'm going to jump to a -2. So -2, if I substituted that in, that's -1/2. -1 is a good one. If I substitute in -1, I get 1 over -1, which is -1. So that's our first non-fraction ordered pair. If I substitute in 0, remember 0 is undefined. You cannot have 0 in a fraction, and so that's undefined. This is where our asymptote is going to appear. And it is going to be a vertical asymptote because it's going to represent all the x values, meaning 0, that x cannot be. So since x cannot be 0, we are going to put in here a vertical line right here on the y-axis that represents x equals 0, because there can be no values where x is 0. So our graph cannot cross that asymptote. All right, so then let's do some positive values. So I've got my x and y's because I ran out of room. So then let's do +1. So if I put a 1 into here, I get 1 over 1, which is 1. And then if I choose 2, I put 1 over 2, so that's 1/2. Let's jump to 4. 1 over 4 is 1/4, and you can see that they're the same values, but positive. Okay? Now I propose to you, so let's go ahead and try to plot some of these. So I'm going to switch my color up. There we go. So I'm going to plot -5, -1/5. So 1, 2, 3, 4, 5, and it's going to be just like right there. Okay? Really close to that x-axis. And if I go -4, -1/4, you're not going to see a whole lot of difference. 1/4 is a little further away from the x-axis, but whoops, I'm trying to get further away and I got closer. So as you can see, that's part of the problem. So really you're not going to see much of a difference. So what's going to happen is the closer I approach negative infinity, so like if I had -6, -7, -8, -9, and so forth, and let's just put a really big number in there, -10,000. If I have 1 over -10,000, that is really, really close to 0, but it isn't 0. So we're approaching a y value of 0 here, but never actually touching it. This is going to lead us to our horizontal asymptote, which we'll see here in a minute. But let's start to go towards 0 in this direction. Let's see what happens as I approach an x value of 0, because I know I can't have an x value of 0, but what happens to the graph as I approach it this way? So let's continue this way, -2. So at -2, I'm going to get -1/2. That one I can hopefully try to graph. There we go, a little further away from the x-axis. And then -1, -1, that's an actual ordered pair point. Now, what if I chose to put in -1/2? What would -1/2 do to, what if I put a fraction in the denominator? So remember, if I have 1 over -1/2, that's the same as saying keep, change, flip. So I keep the 1 in the numerator, change division to multiplication, and I flip the denominator, which is the reciprocal. The reciprocal of -1/2 is -2. So if my denominator is -1/2, the value of that fraction is going to be -2. So when x is -1/2, y is going to go all the way down to 2. Okay? What if I chose a really, really, really small fraction? I don't know, let's say -1 over 10,000, because that's really close to having a value of 0 in that denominator. So if I chose a denominator here that was -1 over 10,000, and we did keep, change, flip, we'd have 1 times and then flip -1 over 10,000, and that becomes -10,000. So at something really, really close to 0, I'm going to get to -10,000, which is really, really close to here. We're actually approaching negative infinity. So these are going to be a curve that's going to go from here to here. So I'm going to connect those points as a curve. And so the left-hand part of this graph looks like this. We like to call that a branch. All right, let's go on the other side of the x-axis, the positive side, and let's start plotting some of these points. So we're going to plot these points over here. So 1, 1 would be up here, nice ordered pair. 2, 1/2, now we're starting to, as we get further to the right, we're starting to approach the x-axis again. And then 4, 1/4, we're getting closer to the x-axis again. 1, 2, 3, 4. So let's get in the right spot. It's really hard for my stylus to get there, but we'll get there. And then 5 1/5, I mean, I'm really close. It's really, whoop, there, right there. I'm going to erase that other point that I put there. All right, so again, what if I chose instead a fraction to go in that denominator? So we're going to choose that same fraction that we did over here, but we're going to choose a positive 1/2. So what if x were positive 1/2? So then I would have 1 over 1/2 equals, keep my 1 in the numerator, change to multiplication, and flip the 1/2, becomes 2. So when x is 1/2, y is 2. So let's plot that value. When x is 1/2, y is 2 is going to go right here. So my point being, the closer I get to 0 coming from the right towards 0, so it's this coming on the right-hand side here of 0, my graph is going to start to get closer, or my y value is going to get bigger and bigger and bigger. Because again, let's think about that -1 over 10,000 that was over here that dropped us here. What if I put positive 1 over 10,000 in this denominator here? Then you're going to flip 1 over 10,000 and it becomes 1 times 10,000. And right here, really close to 0, you're boop all the way up to here. So the closer I get to 0, my y value is approaching positive infinity. But the closer I go to positive infinity for x, in other words, the bigger my x becomes, the closer and closer I get to 0, which makes sense. The bigger this value is in the denominator, the closer that whole fraction gets to 0. So this is a second branch, and it's going to graph like this. Whoop. Let me undo that and redo it because I don't like it touching that x-axis. Okay, so let's try again. There we go. Okay, so as you can see, if x cannot be 0, there is no possible way for y to be 0. This is where y would always be 0, mostly because there is no variable in this numerator. The only way for a fraction to become 0 is if the numerator itself were 0. Since 1 is a constant in this numerator and there's no variable, there is no possible way for this numerator to be 0. So it creates this horizontal asymptote, which goes along here. And we're going to put that in also as a dashed line, and that's a fence also that our graph cannot cross. And so we will label that as y equals 0. So our horizontal asymptote is y equals 0. Our vertical asymptote is x equals 0. So when you're graphing these 1 over x type graphs, these vertical and horizontal asymptotes move. So vertical is this one right here. The only way this vertical can move is right and left, right? Because you can only push it this way and push it this way. If you try to move a vertical line up and down, it just looks the same. It hasn't changed. This horizontal line here, this horizontal line can be moved up and down, but it can't be moved right and left, because if I move it right and left, I'm still on that line. So for our transformations inside the function and outside the function, those are going to be the same things. If I add or subtract something to x, it's going to move my graph right and left in the opposite direction of what I think it is. And so this vertical asymptote also will get moved right and left. If I add or subtract something outside the function here, it is going to move this horizontal asymptote up and down. The only way you're going to see a vertical stretch or shrink is if the number in this numerator changes to like a 2 or a 5. And we really don't worry about vertical stretches and shrinks with this type of graph here. So you're not going to even have to worry about that. The only thing you have to worry about doing is moving the horizontal and vertical asymptote up, down, right, or left, and then making sure that your branches are diagonal to each other. So if this is a positive fraction, your branches are going to be here. If this is negative in the numerator, it's going to flip your branches. Remember, if there's a negative outside the function, it's going to reflect over the x-axis. And this branch is going to reflect over this way. This branch is going to reflect over this way because that's how it reflects over the x-axis. So if this is negative, your branches will still be diagonal, but they'll be in quadrants 2 and 4. Now you can always plug in a value in for x. So I always like to plug in like 1 or -1 and see where my branches are when I plug them into here. This type of graph has a special name. It is called a hyperbola. So you need to learn that name, so that should go on a daily flashcard. Our domain, remember, is going from left to right. It's as I travel along this x-axis from -infinity to +infinity, I reach this barrier, this wall. I have to actually jump the wall to get on to the other side. So this is my only break in our domain. So I'm going to go from -infinity to 0. 0 will not be included. And so it's going to look like this. I'm going to go from -infinity to 0. And I have parentheses at 0 because 0 is not part of our domain. And then we're going to jump the fence, so I have to union that with this interval here. So from 0 to +infinity is the rest of my domain. So my domain is affected by that vertical asymptote, x equals, right? So then that means my range must be affected by my horizontal asymptote. So if you walk the range from low to high, -infinity to +infinity, you're going to approach this fence here at y equals 0. So same thing, from negative infinity to 0, and I hop the fence from 0 to positive infinity. So in this particular case, my domain and range are identical. But you might want to write yourself a note that the range is affected by the horizontal asymptote, and in fact we can draw a line to show that. So the range is affected by the horizontal asymptote, whereas the domain, now let me get a new pretty color. Well, okay, so it's not so pretty, but it'll work. So my domain is affected by my vertical asymptote. All right, so how do we graph these? Let's move on to our next one. So here we have standard form of a reciprocal function. And so we're basically going to take the reciprocal parent function that we just looked at, and we are going to write it in very familiar terms. And instead of f of x, I'm going to go ahead and write y because you're familiar with the letter y, but I easily could have put f of x. And so normally it would be 1 over, but remember that vertical stretch or shrink is caused by a, so a is going to be our constant in the numerator. So it will be a over x minus h, and then on the outside plus k. So with a quadratic, that hk was your vertex, but in our case, h is going to end up being our vertical asymptote, and k is going to end up being our horizontal asymptote. You have to know the difference between vertical and horizontal. So you can always think of horizontal as the horizon, and the horizon is this way. As you look at the horizon, it's this way. So that means vertical must be the other direction. So there's a helpful hint. So let's go ahead and rewrite what you already know. So outside the function is your up or down movement. And outside the function, that up or down movement moves the horizontal asymptote. That's the one that goes in this direction. Okay? Then inside the function is going to be your h, and this is going to be your right-left movement, and it's going to be the opposite of what you think it is. And that is going to move your vertical asymptote, which is this way. Okay? And then the last thing, which I really am not super concerned about, would be A right here is your vertical stretch or shrink. You're going to pretty much ignore that for our purposes here. And then also if A is negative, which we're going to get to here in these notes, then it will reflect as well. So let's go ahead and fill in our blanks here to the right. So H is your horizontal shift. And so a positive is going to shift left, so remember that's the opposite of what we think it is. And a negative, a minus, is going to shift right. Then your K is your vertical shift. Vertical because vertical lines go in a direction of up, down, right? And so a positive is an upward shift and a negative is a downward shift. Now, if A is negative, then your function, let me switch my colors here. If A is negative, then your function is going to be reflected, and we'll see how this happens, reflected across the x-axis. So none of this has changed. So this is nothing new that you should have to study. Now, if your A is greater than 1, that's a vertical stretch. And if A is between 0 and 1, that represents a vertical shrink. But again, you can pretty much ignore all of this. because we're not going to have to worry about it when we graph it. You won't really have to do a table of values. You might also want to write here that your vertical asymptote is going to be x equals h, and your horizontal asymptote is going to be y equals k. So your asymptotes have to be written and labeled as a line because that is what they are. All right, so before we graph these, we're going to look at translations and put them into our parent function so you can kind of see how they work. Okay, so when writing functions, we're going to just start with that parent function. So I'm going to put that parent function over here again so that we can kind of look at it. So we have y equals a over x minus h plus k. So you are going to be replacing values in here for h, for k, or for a. The x and the y are not going to switch. So here we go. The reciprocal parent function, so they're telling you what that parent function is, the reciprocal parent function, the reciprocal parent function, the reciprocal function, okay? So here we go. Couple things. So is reflected across the x-axis. So if it's reflected across the x-axis, we have a negative a value. If they don't give us a vertical stretch or shrink, your a will be 1. All right, so let's keep reading. Then it's translated 4 units right. So 4 units right is going to be your h. And then 3 units down is going to be your k. Then we're going to write an equation and identify the asymptotes. So there's nothing about a vertical stretch or shrink. So we're just going to write y equals, my a is going to be -1. And I guess I'm going to put this in pink since I wrote in blue. Okay, so then I've got -1 over, and then my x is here. So 4 units right is typically a positive, but because it's inside the function, I want to change the sign. So right would be a -4, and then 3 units down is the same sign, so I have a +3 on the outside. So this is my reciprocal function. Then to identify the asymptotes, we're going to take this one here, and one asymptote is going to be x equals 4, because your h is 4, right? It's not -4. And if you think about it, if x were 4, 4 minus 4 is 0, and that is what would cause the denominator to be 0. If you take this entire denominator and set it equal to 0 and solve for x, you would add 4 to both sides. So x cannot be 4 is our horizontal asymptote. And so, our vertical asymptote. So that's our vertical. And then our y equals 3 is our horizontal asymptote. And so we're just going to shorten these as VA and HA. So I already wrote vert, but I'll write vert A. Well, let's erase that. Let's just put VA. We'll maintain consistency. So VA. Okay? All right, so then you try 2 and 3. Pause the video, try them on your own, and then restart the video. All right, so I have y equals, and then an x. So let's see what we've got. So we are vertically stretched by a factor of 2. So that's going to be my a. So that's my a. Then it's translated 7 units up. That's going to be my k. And 1 unit left. That's going to be my h. So 1 unit left. Left is normally a -1, but we want to do the opposite, so I have a +1. 7 units up is going to be on the outside, same sign, up is positive. And then my a has a vertical stretch of 2, so I'm going to put a +2 there. So that is our reciprocal function. And then we're going to list out our asymptotes. So x equals, now remember, you're going to set this equal to 0. the value of x that makes the whole denominator 0 is going to be -1. So we always change the sign. So the opposite of 1 is -1. So that becomes our asymptote. That's our vertical asymptote. And then same sign on the outside, y equals 7 is going to be our horizontal asymptote. We need to be able to identify these because the asymptotes create the shape to our graph. They're very important. All right, so then on, let's see, I'm going to change this. All right, so then for the next one, y equals, I got my x. All right, so it has a vertical asymptote. So this time they're talking about asymptotes. So the vertical asymptote located at x equals -2. So they're giving it to you in a slightly different way. So this is going to be my h. And so we're going to change the sign of that -2 and make it a +2. Because if x cannot be -2, right, I'm going to have to add a +2 to make this a 0 in here. So if you just took this and made it so that one side is 0, you would add 2 to both sides. So you're going to have x plus 2. That's how you go from a vertical asymptote to this. All right, the next, and a horizontal asymptote. So a horizontal asymptote, and notice it says y equals, so that's outside the function, and it's the same sign, so y equals 5. Write an equation that could represent this function. They don't mention anything about a. So a, or a vertical stretch or shrink, or no kind of reflection. So that means that a is going to be 1. All right, and they've already identified our asymptote, so there's no need to on this one. Okay, so we are ready to start graphing, and you'll see that the graphs to these go very, very quickly. So here we go. All right, so I'm going to graph this first one. I'm going to make my graphs as big as I can. And then we're going to identify, at the bottom you can see, we're going to identify our domain or range and our vertical and horizontal asymptotes. So here we go. So as you look at the function itself, right here, nothing is being added to x. But we still can't have x being 0. So if nothing's happening here, we still always have our vertical asymptote of x equals 0 and our horizontal asymptote of y equals 0. They're always there. It's a matter of whether they've been moved. So since nothing's being added or subtracted to the x, I know that my vertical asymptote has not moved, that it is still here. And you need to label it as x equals 0. Then this is going to be my horizontal asymptote. Okay, so it's moved to a -2 because it's the same sign as what we see there. So the first thing we do when we graph these hyperbolas is to graph their asymptotes. Okay, now because my a is a +1, I don't have a vertical stretch or shrink, which I wouldn't worry about anyway, but most importantly it's positive. That means my branches are still in the upper right corner and the lower left corner. If you don't believe me, put in +1 into the function, or actually, yeah, put +1 into the function. Typically, I'm going to put whatever I can in here that's going to create a non-fraction. So if I let x equal 1, 1 divided by 1 is 1, minus 2 is -1. So when x is 1, y is -1. So all I need is 1 point over here to tell me that that's where my branches are going to go. So I'm going to hug that asymptote right here. I mean, I don't even have to do any more points than that. And I didn't have to do any points at all if I realized that my branches are always going to be diagonal to each other in the upper right and lower left, as long as this is positive. Okay? And I'm going to prove to you the other branches here. I'm going to choose -1. So if I put -1 in here, 1 divided by -1 is -1, minus 2 is -3. So when x is -1, y is -3, which puts it there. So then we're going to hug those asymptotes, go through that point. You must have arrows on the ends of your lines. And that's it. That's all you have to do. It's pretty darn simple. So our vertical asymptote is x equals 0. our horizontal asymptote is y equals -2. Now, as you're doing your domain and range, you are to walk along the x-axis from -infinity to +infinity. If you reach any barriers, that's a stop to your domain or range. So from -infinity, I come up to 0 and I have to stop and jump the fence. So I'm going to go from -infinity to 0 is my first part of it. So -infinity to 0, I'm going to stop and jump that fence, and then when I jump that fence, I land right on the other side next to 0. So I have to start again. Whatever I end with, I have to start with again. And so then I'm going to go from 0 to +infinity. I don't reach any more barriers. Now your range is going to look different. We're going to go from low to high. So as I start at -infinity and I go in this direction, I hit this green fence at -2 and I have to hop it. So that's my first barrier from -infinity to -2. So I hop that fence and I start on the other side at -2. So once I get to the other side, then I keep moving with no barriers to +infinity. So those asymptotes, you should see this 0 asymptote creates that barrier there at 0, and this -2 creates that barrier there. So you should see that. So I want you to see if you can try this one on your own. If you're still shaky, you can not pause the video, but if you feel confident, go ahead and figure out what you think your movements are going to be with a +3 inside the function. Okay, so a +3 inside the function means that we are going to move, its inside is the opposite of what we think it is, so we're going to move left 3. That means that our vertical asymptote here is moving left 3 to -3. So it becomes right here. Remember, these asymptotes give us the shape to our graph, and you want to label it. Okay, now there is no movement outside the function, so our horizontal asymptote right here is not moved at all. You still need to label it as y equals 0. How do I know it's y equals versus x equals? Remember, it's a line going through the y-axis at 0. This is a line going through the x-axis here at -3. So that means that my vertical asymptote is x equals -3, and my horizontal asymptote is y equals 0. Now, to be honest, I could write my domain and range right now without looking at my graph. Because, remember I said this causes the break in our domain from -infinity to +infinity, so I know at -3 I'm going to have to hop a fence. So I could tell you right now, and I'll prove it to you when we graph it, I'm going to go from -infinity to -3, union -3 to +infinity. And then for the horizontal asymptote, it's going to affect your range. I'm going to have to hop a fence at 0. So I'm going to go from -infinity to 0, hop that fence, and go from 0 to +infinity. Well, let's see. Again, because this is +1, there's no reflection over the x-axis. So I know my branches are going to be on this quadrant and on this quadrant. So you can go ahead and just plot them if you want to. I'm going to prove to you one more time. I'm going to plug in a value. I could plug in 1, but the problem with plugging in 1, it still creates a fraction here. So the best thing for me to do is perhaps I want to turn this 3 into a 1. So if I let x be -2, -2 plus 3 is 1. 1 divided by 1 is 1. So if x is -2, y is 1. So see, I'm on this side, and that means my branches are going to go here. So my branch is going to go through that point. So hug the asymptotes, go through that point, and boom, done. Now on the other side, if I want to make this, because I want to try to make this +1 or -1 because 1 is in my numerator. So to make this negative 1, I could have this as a negative 4. So negative 4 plus 3 is negative 1. 1 divided by negative 1 is negative 1. So when x is negative 4, y is negative 1. So see how we're diagonal to it. We're going to be right here. So hug those asymptotes, go through that point, and hug in that direction. Use your arrows. And that's it. They're diagonal. We're done. I love it. These are great graphs. All right, keep going. So we have 4 more graphs that we're going to practice. These ones happen to have vertical stretches and shrinks, and some have reflections. So this next one on number 6 actually has a reflection because my A is negative. I really don't care about the negative 4 because our asymptote, or about the 4 itself. I care about the negative but not the 4. So the only movement we have is outside the function. So there's nothing inside the function, so nothing's affecting x. Our domain is our x, which is our vertical asymptote. So I know for a fact my vertical asymptote is going to stay at x equals 0. But outside the function, I have a plus 1. So I know we're going to move up 1. So this means a movement of up 1. So that means my horizontal asymptote is going to move to y equals 1. So let's put those in here. My vertical asymptote stays here. There was no right-left movement, so that vertical line is not going to get moved right or left. And then my horizontal asymptote is going to move to a positive 1 because horizontal lines can get moved up and down. So this is our y equals 1, 1. And then you might want to add, whoops, didn't mean to do that. My controls went a little nutty. So you might want to move, let's see, or you might want to note that right here, whoops, why is it not working? Try one more time. Okay. Let's see. Oh, there we go. Okay, so that's creating 2 things. And I only care if I asked you about it, but there is a vertical stretch of 4 and a reflection. Over the x-axis. Okay? So what's going to happen is, instead of our branches being here, this branch is going to get reflected over the x-axis. So if I have a point up here, it's going to end up down here. If I have a point here, it's going to end up here. So my branch is going to go in this direction. I know I'm going to have a branch here, and I'm just hugging those asymptotes. Now, if you want to plug in a point, feel free. The only value, there's a couple of values that will cause this not to be a fraction. So I could either put 1 in for x, and I'm talking about on the right side here, so I could put a positive 1 in for x or a positive 4. So I can show you both, okay? So in fact, let me remove this. Undo, what point is it undoing? I'm not quite sure. All right, I guess it's not letting me erase it. Will it? Oh, it'll let me erase it here, which is good. Okay, so what if I plugged in a positive 1 here? So negative 4 divided by 1 is negative 4 plus 1. So I put in a 1, negative 4 plus 1 is negative 3. So when y, or when x is 1, y is 3, negative 3. So 1, 2, 1, 2, 3. So I'd be all the way down here. Remember I told you it was getting reflected. And then if I substituted in a positive 4, negative 4 divided by positive 4 is negative 1, plus 1 is 0. So I actually found an x-intercept. So when x is positive 4, y is 0. So you could plot those 2 points if it makes you feel better, and it gives you a better shape to your graph, and then hug those asymptotes. So that's a nice, pretty shape. You can do the same thing on the other side. I guarantee you our branch is going to end up over here. But again, choose values that are negative that are going to not create a fraction here. So that would be negative 1 and negative 4. So let's put in negative 1. Negative 4 divided by negative 1 is positive 4, plus 1 is 5. So when x is negative 1, y is 5. So negative 1, 1, 2, 3, 4, 5. Didn't I tell you it was going to be over there? Then put a negative 4. Negative 4 divided by negative 4 is 1 plus 1 is 2. So 1, 2, 3, 4, 1, 2. Okay, so then hug those asymptotes and go through those 2 points. You're done. So your domain is going to go from left to right, and the only barrier I come to is here at 0. Got to hop the fence and go on to positive infinity. So it looks like negative infinity to 0, hop the fence, 0 to infinity. And again, you can see that that 0 is creating that break. So for our range, we're going to go from low to high. The only barrier I come across as I walk that y-axis is here at 1. Notice that 1 is going to cause the break. From negative infinity to 1, I hop the fence, and from 1 to infinity. And you're done. So you go ahead and try this next one. You do have a vertical stretch, but it doesn't affect a thing. So pause the video, do your domain and range, vertical asymptote, everything, and then restart the video. Okay, so here we go. We have this inside the function, which is going to create a right shift of 2, which means that our vertical asymptote is going to be at x equals 2, because if x were 2, the denominator of that fraction would end up being 0, and we can't have that. So put that in here. X equals 2, make sure you labeled it. Okay, then outside the function, right here, that is going to be down 2. So that creates our horizontal asymptote to be moved down 2. So y equals negative 2. That's a negative, and that's a 2. Weird but true. So y equals negative 2. And I can write my domain and range from here, negative infinity to 2, jump the fence, union 2 to infinity. And same thing for range, negative infinity to the negative 2, jump the fence, negative 2 to infinity. Okay? Now, I know that we have here a vertical stretch of 3. Vert, stretch of 3. It doesn't affect anything. It's not a negative. Your branches are still going to be over here. If you really want to plug in points and figure out what they are, feel free. But I know that my branches are going to go this way, and that's how I'm going to grade you. I'm grading you really mostly about where your branches are. If you really want to find the x and y intercepts, feel free. That's not the biggest thing that I'm worried about. I just want to make sure that you understand that a rational function in the form of 1 over x is a hyperbola with these branches that are diagonal to each other. And they're always in the upper right and lower left quadrants. Unless a is negative, then they get reflected to the upper left and lower right quadrants. All right, so let's graph our last 2. Yay, our last 2. All right, so I highly suggest that you try these 2 on your own. Pause the video, do both of them, answer all the questions, and then restart. Okay, so let's start with our x. The plus 4 is going to move us left 4, which means that our vertical asymptote becomes x equals negative 4, because we're moving this asymptote here left 4. So 2, 3, 4, here we go. Remember, those asymptotes give you the shape to your graph, and you need to label it. X equals negative 4. All right, then, so then our horizontal asymptote is going to be affected by this. So it's a minus 7, so we're going to go down 7. So that means that our y equals 0 moves to y equals negative 7. Okay, so we've got it moving all the way down here. y equals -7. And then this creates a vertical stretch of 2, which I don't care about because there's no reflection. So you can plug in points if you want to, but quite honestly, there's where my branches will go, and those asymptotes give us shape to the graph, and we're almost done. Then we want to label our domain and range. So our domain goes from left to right, and it is affected by that vertical asymptote. So I'm going to jump a fence at -4, which causes a break. Then our range goes from low to high, so I'm going to jump a fence at -7 and continue on to positive infinity. See how quick that was? That's awesome. All right, then our last graph, we have a -5 in here, so that is going to cause our graph to move right 5. So that means our vertical asymptote is going to be x equals 5. So we always dash the lines because they're not technically part of the graph, they just give shape to the graph. Make sure you're labeling them. And then of course our horizontal asymptote is going to move up 3. So that's going to put us here at y equals 3. Of course, we can do our domain and range without even looking at the graph. So our domain is affected because our domain's right left. So we're going to hit that fence at 5 and have to hop it. And then our range goes from low to high. So we're going to hit that fence at 3 and hop it. Okay. All right, and so then so here's the issue now, right? So because I have a negative, that means that we have a reflection. So reflection over the x-axis. So when I draw my branches, normally I would draw this branch here, but it's going to get reflected over this x-axis to here. So my first branch is going to actually end up going down here. If you don't believe me, substitute in 5 for x. No, not 5, because x can't be 5, 6. Substitute in 6 for x, and you'll see I'm right. Then, normally our branch over here is going to be reflected up in this direction. And again, if you don't believe me, substitute in a value of 4 for x, and you will see that the branch ends up being here. And that's it. Now, go forth and be merry and complete your homework. If you have questions, don't hesitate to ask.